Dear viewers, greetings. Today we can discuss about polysaccharides, starch and glycogen. Polysaccharides, variously called as glycan or polyhalosides or polyosides. These are the another name of polysaccharide. High molecular weight carbohydrates which on hydrolysis which yield mainly monosaccharides or products related to monosaccharide. Regarded as polymeric anhydrates of simple sugars. The polysaccharides are two types. One is homopolysaccharide, another one is heteropolysaccharide. First we will see about homopolysaccharide. Homopolysaccharides on hydrolysis which yields a single monosaccharide then serve as both storage as well as structural purpose. Storage monosaccharides are starch, glycogen and inulin. The structural properties are structural usages for cellulose, pectin and chitin. First we will see about starch. Most important reserve food material of the higher plants and is found in cereals, legumes, potato and other vegetables. More than half of carbohydrate ingested by human is starch form. Then sources of starch mainly found in seeds, fruits and tubers. Other good commercial sources of starch is potato, maize, wheat, rice, oat, barley, tapioca or cassava in tropical regions and arrowroot, banana, buckwheat, sago palm stem. These are the other commercial sources. Then property of starch. Appearance. Starch is a soft, white, tasteless and odorless powder form. The solubility of starch is insoluble in cold water or alcohol or other solvents. The composition of starch is naturally which consists of two components. One is amylose, another one is amylopectin. Amylose concentrations are 15 to 20%, which are long unbranched straight chain, and another one is amylopectin, which are 80 to 85% concentration and which are branched one. The molecular formula or chemical formula of starch is C6H10O5 N times. Then molecular weight of starch. Alpha amylose or simple amylose has a molecular weight range of 10,000 to 50,000 Dalton. The chains have 250 to 2000 anhydroglucose units. Beta amylose or isoamylose or amylopectin has a high molecular weight range of 50,000 to 1 lakh Daltons and which consists of 300 to 5500 glucose units per molecule of amylopectin. Next, reaction with iodine solution. The course of hydrolysis causes gradual change in color when treated with iodine. First it appears blue color, then purple, next red, finally no color formation. And also by the increase in concentration of reducing sugar. Starch initially which gives the blue color mean soluble starch or blue color Then amylodextrin which produce purple color, erythrodextrin produce red color, acrodextrin does not produce any color. A compound which yields only glucose molecule on hydrolysis is called as glucosan. In starch is called as glucosan. Reaction with acid and alkalis. Starch hydrolyzed in the presence of hydrochloric acid to form monomers. Starch with alkali to form precipitate. Here gelatination of starch. Here 1:10 ratio of sodium hydroxide and starch. Next, structure of starch. The starch which consists of alpha 1,4 and alpha 1,6 glycosidic linkages. First one, amylose. The linkages in amylose is alpha 1,4 glycosidic bonds. Next one, amylopectin. As like amylose, which consists of alpha 1,4 glycosidic linkage and addition to alpha 1,4 linkages which have alpha 1,6 glycosidic linkages also. One branch formed after every 24 glucose units. This is the structure of amylose and amylopectin. Amyloses are linear or straight chain. Second one, amylopectin. In the linear chain, in between many branches formed. So amylases are straight or linear form. Amylopectins are branched one. This is the structure of amylose as well as amylopectin. First one, amylose. Amyloses are made up of glucose unit. This is the structure of glucose, or one glucose molecule joined together by another one glucose molecule with the help of 1,4 glycosidic bond. 1,4 glycosidic bond means one glucose molecule first carbonatum, another glucose molecule fourth carbonatum joined together to form the alpha 1,4 linkages. As like in the linear form of glucose, the sixth carbonatum of glucose linked to another one chain of first carbonatum of glucose. In this way it forms the alpha 1,6 linkages. These are the branched point. Next, hydrolysis by enzyme. Here starch is hydrolyzed by either alpha amylase, beta amylase or alpha 1,6 glycosides. These are enzymes used for hydrolysis of starch. First one, alpha amylase, found in digestive tract of animals, which hydrolyzes the linear amylase chain by attacking alpha 1,4 linkages at random throughout the chain, to which produces the mixture of maltose and also glucose unit. Maltose means disaccharide which composed of two molecules of glucose. Next, beta amylases, an enzyme found in plants, attacks the non-reducing end of amylose, which yield successive unit of maltose. Then amylopectin can also be attacked by alpha and beta amylases, but the alpha 1,4 glycosidic bonds near the branching point in amylopectin and the alpha 1,6 bond itself are not hydrolyzed by this enzyme, either alpha or beta amylases. A separate debranching enzyme, example alpha 1,6 glycosides, can hydrolyze the bond at the branching point. Branching point means 1,6 linkages. Therefore, the combined action of alpha amylases and alpha 1,6 glycosides, which hydrolyze amylopectin ultimately to a mixture of glucose and also maltose molecules. Next, function of starch. First one is which are the energy source. Animals and humans digest starch using enzymes like amylase, which convert into glucose. The glucose is a fuel for cellular process or cellular metabolism. Next one is texture and also thickening agent. When heated in water, starch gelatinizes, which creates thick, smooth textures in foods like soup, gravies, and sauces. Next one is pharmaceutical industry. It is frequently used as an excipient and binder to help form solid tablet and also capsules. Next, industrial application. Non-food uses include adhesive properties for paper making and stiffening texture or textiles. Next one, polysaccharide is glycogen. Glycogen is the carbohydrate reserve in animals. In soft and referred to as animal starch. As like plant, this type of polysaccharide stored in animals, so called as animal starch. Sources of glycogen is present in high concentration, liver 6 to 8% and muscle 1 to 2%. It is also present in yeast and also fungi. The properties of glycogen: appearance, it is a soft white powder. Composition: glycogen is a branched chain polysaccharide made up of alpha D glucose units. Molecular formula of glycogen is C6H10O5 enzymes. Molecular weight of glycogen is 1 to 2 into 10 to the power of 7 Daltons. Solubility: it is more soluble in water than amylopectin compared to amylopectin, which are more soluble in water. Hence, it is readily forms a suspension even in cold water also. Glycogen is precipitated from aqueous solutions by addition of ethyl alcohol and is fairly stable in hot alkali. Reaction with iodine: it is a non-reducing sugar and gives red color with iodine solution. The red color, however, disappears on boiling and reappears on cooling. Next, hydrolysis. On incomplete hydrolysis with alpha 1,4 glucan maltohydrolase, glycogen yields only maltose units. However, the acid used means completely hydrolyze it to form glucose unit. Enzymes such as alpha 1,4, alpha 1,6 glycosidase are debranching enzyme hydrolyzes the glycogen to form the glucose molecule. Then, structure of glycogen. The structure of glycogen is similar to that of amylopectin with more branches. The primary glycosidic bond is alpha 1,4 linkage. After an average 8 to 10 glycoside residues, there is a branch containing alpha 1,6 linkages. In amylopectin, which have every 24 units to form branches, but here glycogen every 8 to 10 units to form the branches. So compared to amylopectin, in glycogen, which have more branches. A single molecule of glycogen have a molecular weight is up to 10 to the power 8 Daltons. These molecules exist in discrete cytoplasmic granules. Due to the way glycogen is synthesized, every glycogen granules has at its core a glycogen protein. This is the structure of glycogen. As like amylopectin, here also linear form of glucose molecules in between 1,6 linkages also formed in branches. Compared to amylopectin, here more branches formed. Then functions of glycogen. It is the major storage polysaccharide in human body. It is mainly present in liver and also muscle. It is also called as animal starch. Thank you, dear viewers. Once again, thank you all your support.